Hello, we are going to talk about mensuration, continuing from the last session where I talked about measuring, calculating of areas. This time I'm going to talk about measuring and calculating of volumes. Right, so let's start with some units. So both the units of areas and volumes are made up using the units of length. So for example, for area, we use units like cm squared or meter squared. So you make that up from centimeters or from meter. So in volume, we use units like centimeter cubed or meter cubed. So let's look at how that happens. Right. So suppose we have a cube like that, a small cube with all the sides equal, and let's say the side of this cube is 1 centimeter long. So all the sides are the same. It's a perfect little cube. Alright, so now if we want to find the volume of such a cube, there is a formula. We just multiply all the sides together. So if I have, say I call this the length, I call this the width, and I call this the height. Alright, they are all the same. So the formula for this is volume is equal to, let me first write that down in words. Volume is equal to the length times the width times the height. Well, in this case, really, for a cube, the length, the width and the height are all the same. Okay, so it would just simply be 1 cm times 1 cm times 1 cm. So that's the volume. Now, if I calculate the answer for this, it will be 1 times 1 times 1. Answer is 1. And the units would be cm times cm times cm. So 3 cm's multiply together, we have cm cubed. So that's just like algebra. When we multiply 3 symbols together, it becomes a cube. So here the cm is like a symbol in algebra. Alright, we get a cm cubed. So that's how the units cm cubed, centimeter cubed, come about. Okay, so how about if instead of centimeters, we have meters? So let's take a look. If I have a cube, a larger cube, whose side is 1 meter long, what's the volume? We can use the same formula and find the answer in exactly the same way. The only difference instead of 1 centimeter, we have 1 meter. So let's do that. Volume is equal to 1 meter times 1 meter times 1 meter. So in the same way, we get 1 times 1 times 1 is 1, and m times m times m is m cubed, like algebra. So 1 meter cubed is the volume of this cube. Okay, so you can start with centimeter and you get meter cubed, start with meter, or you get centimeter cubed, or you start with meter and you get meter cubed. Now let's look at the relation between these two. Now you remember when we talk about length, we must learn how to convert between units. For example, if you have 1 meter, that is equal to 100 centimeters. Or if you have 1 centimeter, that's equal to 1 over 100 of a meter. So for volume, we should also learn how to convert between units. For example, right, this cube with a side 1 meter is clearly a lot bigger than a cube with a side of 1 centimeter. Now, so can we say in the 1 meter cubed, this 1 meter cubed volume, how many 1 centimeter cubed volume are there? In other words, 1 meter cubed is equal to how many centimeter cubed? So that's the kind of conversion we want to learn. So let me write down the question. The question is 1 meter cubed is equal to how many centimeter cubed? So that's the question. Fill in the blank. Okay, now we can do this starting from the relation between 1 meter and 1 centimeter. So let's write that down. 1 meter is equal to 100 centimeters. Okay, so that's our starting point. And in order to get to the volume, we take the cube of both sides. Now what do I mean by that? Let me write this down again. What I mean is, on each side, let's say on left side, you take the cube of that. You raise it to the power of 3. Now the reason why we want to do this is to turn the left side into 1 meter cubed. Alright? The cube of 1 meter is just 1 meter cubed. Now, but if this is like an equation in algebra. So you have a left side and you have a right side. Now, if you do something to the left side, if you raise the left side to the cube, you have to do the same thing to the right side. You have to raise the right side to the power of 3 as well, so that the right side is still equal to the left side. So that's the idea behind the equation. If you do something to one side, you must do the same thing to the other side, then the left and right side will stay the same. Okay, so let's take a look at the left side. Now 1 meter cubed. What's 1 meter cubed? That's 1 meter times 1 meter times 1 meter. Right, that's the meaning of 1 meter cubed. Multiply by itself 3 times. And well, you can see that this is really equal to 1 meter cubed. Okay, so that's where we're after. On the right side, in the same way, we have 100 centimeter times 100 centimeter times 100 centimeter. Right, so that's the right hand side, and we have to calculate that. So let's do the left side first. So 1 times 1 times 1 is 1, m times m is m cubed. Alright, so that's the same as before. On the right side, we have 100 times 100 times 100. That would be 1, okay, 0, 0, 0, 0, 0, 0. Altogether 6 zeros. That's 1 million. And the centimeter times centimeter times centimeter gives cm cubed, which is exactly what we wanted. That's the answer that we want. So 1 meter cubed is equal to 1 million centimeter cubed. So that's a lot of centimeter cubed in 1 meter cubed. So what you see here is basically the fairly direct way and quite simple way to find the answer when you need to convert volumes between units. So this is the way to do it. Okay. Now, apart from meter cubed and centimeter cubed, we need to learn one or two other units that are commonly used for volumes. Now, right, but before I do that, let us look at meter cubed and centimeter cubed again, and let's talk about some of the ways of talking about this unit. Now, if I have, say, 1 meter cubed, so that's how I say it verbally. I call this 1 meter cubed. So I'm actually reading out what I see here. There's a 1, there's a meter, there's a cubed. So the meter is being cubed. It becomes a cube. So we are talking about cubed as in it's a past tense. You are doing something to the meter. You're turning it into you're raising it to the power of 3. All right. So that's how one way to read this. Now there's another way to read this, which is it's called 1 cubic meter. Right? So 1 cubic meter means the same thing as 1 meter cubed. Now, there is another similar term which you see sometimes. Let me write that down. It is a 1 meter cube. 1 meter cube without the past tense, without the D. So what's the difference between a 1 meter cube and a 1 meter cubed? Right. Now, a 1 meter cube means a cube that has a side of 1 meter. So that's the meaning of a 1 meter cube. So what it really means is that this is a cube, right? It's a cube which has a side of 1 meter. So that's what 1 meter cube means. It means that this particular volume has to be a cube. Whereas if you are talking about 1 meter cubed with the D, or 1 cubic meter, it refers to a volume with the same, an object with the same volume as this cube there, but the shape does not have to be a cube. It can be a sphere, it can be a cylinder, or it can be any other shape with this 1 meter cubed volume. So this phrase here and here, these two terms, refers to a volume of any shape. But when you say 1 meter cube, it refers to a cube, alright, that happens to have a side of 1 meter. So you need to see the difference between these two terms. Now moving on to another unit that we get to see quite often. Now if you go to the market or supermarket to buy some milk or to buy some drinks, to buy a bottle of drink or a carton of milk. Now, what you see on the milk, you see bigger boxes or smaller boxes of milk. Now you see the volume written on the bottle, and you would usually not see 10 cm cubed or half a meter cubed. Alright, you would normally see the unit of liter. Right. So this is liter, L-I-T-R-E. So liter is a unit that is often used to measure the volume of a liquid or a gas as well. Right, so what is 1 liter? How is it related to centimeter cubed or meter cubed? Right, so the simple answer is 1 liter is equal to 1000 centimeter cubed. So that's the meaning of 1 liter in terms of centimeter cubed. 1 liter is 1000 centimeter cubed. Now, you may sometimes also see a unit that's written as cc. Cc means cubic centimeters. right? Let me write that down. So cc, cubic centimeter. So as I just explained, cubic centimeter means the same as centimeter cubed, but you do see cc sometimes. Now there is yet another way of writing this. 1000 ml. Right. Now what is ml? Now before I explain that, let me go back to the liter. Now there is a short form for liter. 1L. So the unit for liter, the symbol for the units of liter is just L. Alright, just like the symbol for centimeter is cm. So for liter it is L. Now, but then what is ml? Right, think about meter and millimeter. Alright, meter, millimeter. So mm. Right, 1 meter is 1000 millimeter. And in terms of the symbol, you have 1m is 1000 mm. So the m here, the little m there really means milli. ml stands for milliliter. Right, and milli, if you remember, means 1 over 1000. So 1 milliliter is 1 over 1000 of a liter. So it's alright. So therefore 1 liter is 1000 milliliter. So the connection between liter and milliliter is just the same as between meter and millimeter. Alright, so instead of liter here, if you replace the L by M, you will have meter and millimeter. But with the L, you have liter and milliliter. So if you look at these three, 1 liter is the same as 1000 cm cubed. It's the same as 1000 cc for centimeter, for cubic centimeter. It's the same as 1000 ml for milliliter. Right? So in other words, cm cubed, cubic centimeter, milliliter, they are exactly the same. Just 3 different ways to say the same units. Right. Now, just as an interesting aside, something that you don't normally see very much in maths exam is the unit. There is a unit called CL. Right? So 1 liter is also equal to 100 CL. Now, next time you buy a bottled drink or a can of Coca-Cola, take a look at the can. Now, you would often see the unit CL. What is CL? The C here is like the C in centimeter. So CL means centiliter, right? And if you remember, centi means 1 over 100. So 1 CL is 1 over 100 of a liter. Therefore, 1 liter is 100 centiliter. Now you do see this quite often when you buy on the bottles of drinks that you buy, but you don't see it so much in the exams. So this is just an aside. Now, as another aside, which you may see if you do, say, take a course in chemistry, in school chemistry, there is another unit of volume that you would see quite often. And that unit is that unit is dm cubed. Right. Now dm, the d there stands for deci. Now this is a unit that I have not mentioned before. Now, deci stands for 1 over 10. So 1 decimeter is 1 over 10 of a meter. Alright, and 1 over 10 of a meter is equal to 10 centimeters. So 1 decimeter is equal to 1 centimeter. Let me just write it somewhere. I'll just scribble it up there, down here. So 1 dm is equal to 10 cm. Right. So therefore, 1 dm cubed, if you imagine taking the cube of 1 dm, that's the same as taking the cube of 10 cm. Now the cube of 10 is 1000. Alright, you can see that if you take the cube of 10 cm, you get 1000 cm cubed. So therefore, 1 dm cubed is the same as 1000 dm cubed. Sorry, 1 dm cubed is the same as 1000 cm cubed. So 1 decimeter cubed. So not something you often see in a maths exam, but something that you will see a lot in a chemistry exam, if you do chemistry. Okay, so moving on, I have looked at the formula to find the volume of a cube. Alright, it's the same formula to find the volume of what we call a cuboid. So let me just draw a cuboid. It's like a three-dimensional rectangle, alright, with length, width and height. So the volume of this is given by the length times the width times the height. Right, so it's the same kind of formula that is, well, it's the exact same formula that we used for a cube. Okay, now let's go on to look at another shape or shapes. So let's start with right, in fact, let me start with redrawing that a little bit. Now I'm going to draw it so that it looks a bit taller. Okay, and that's the length, that's the width, that's the height. Now I'm going to rewrite this formula a little bit. Volume, let's do the volume. Okay, now the first part of this volume, length times the width, the length times the width, is really the same as the area of the base, the area of the bottom area of this cuboid. So I can call that the base. Alright, length times width is the base, then times the height. Okay, now what I'm doing is I'm just looking at this in another way. Alright, it's really the same idea. Alright, but instead of thinking of writing the formula as length times width times height, I'm going to write it as base times height. Alright, you will get the same answer if you use this formula. But then, if it's the same, what is the point of doing this? Now the point is that I can use this formula if I have a slightly different shape. If I have a base that is not rectangular. For example, what if my base is circular, so that I have a cylinder for the volume? How do I find the volume of a cylinder? Now, if you look at this and this, you can imagine that the difference is the shape of the base. So instead of a rectangular base here, you have a circular base. And in fact, you can use this formula, volume equals to base times height, to find the volume of a cylinder. Right, so that's the base. That's the base area. That's the height. Alright, and the volume of the cylinder is simply base times height. So that makes it easy to find the volume of a cylinder. Alright, and for convenience, we often like to have a formula using symbols. Alright, a formula using symbols like in algebra. So we can make one for the cylinder. So let's do that. Let's start with the height. Okay, I'll call that h. So h is height. Now for the base is a circle. Alright, and we know how to find the area of a circle. first we have to know the radius. I'll call that r. And the area of a circle is pi r squared. So let me write that down. So volume is V, base is pi r squared, and height is h. You can leave out the times because in algebra, if you leave out, if there's nothing in between the symbols, it means that you multiply them. So pi r squared h is the same as pi r squared times h. Right, so that's the formula for finding the volume of a cylinder. So of course you can remember that, or you might find it easier to remember that volume is equal to base times height. Alright, it's useful because with this one volume you can use it for both a rectangular cuboid and a cylinder. Right, now and I should also mention, in case you see this question, which might come out sometimes, that this formula, volume is equal to base times height, can be used even for objects that has a base of a different shape, of any shape. So it does not have to be a rectangle or a circle. It can be a polygon, it can be a hexagon, it can be a triangle. So if you have a triangle, you get a prism, right? It can be any irregular shape. Okay, as long as the shape of the cross section remains the same. Okay, so for example, if you take a cut through the volume, the shape of the section has to look the same as the base, it has to look the same everywhere. So it must have a uniform cross section. Alright, for such an object, you can always apply this volume equals to base times height formula. Okay, let's look at another shape which is quite common. A cone. Right. How do we find the volume of a cone? Now, I'm just going to write down the formula for this. So that's the base. Now I'm going to draw a vertical line down to the base. Okay, and that's the height. Okay, so that's a cone. Now the volume is equal to 1/3 times base times height. That is the formula. 1/3 base times height. Now, I'm not going to explain how this formula comes about. It is rather involved and not required for the exams usually. Okay, so it's just 1/3 times the base area times the height of the cone. Now again, it is convenient sometimes to have an algebra formula for the formula. It's convenient to have the formula in terms of symbols, right? Okay, so height would be h. Now the base is a circle, so let's say r is the radius of the circle. So with these two symbols h and r, we can make an algebraic formula. So volume is 1/3. Base, area of the circle is pi r squared. And height is h. So there we have our formula. V equals to 1/3 pi r squared h. Volume of a cone. Now, interestingly, we can apply this same formula even if the base is not a circle. So it's like the idea just now for an object with a uniform cross section. So in this case, for an object that looks like a cone, you can actually apply the same formula even if the base is not a circle. So let's look at a simple example. Right. Okay. Now, what kind of a shape is that? It's not the familiar pyramid, because a pyramid has a square base. This one has a triangular base. Now, this kind of shape is called a tetrahedron. Let me spell that. So tetrahedron. Tetrahedron. Right. So how do we find the volume of this? So as I said just now, you can use this same word formula. Volume equals to 1/3 base times height. So the base here, the base will be this one. Now let me call the area A. So, and let me call the height H. Okay. So 1/3 base times height, and I can make up an algebraic formula for that. V is equal to 1/3 times A, the base area, times H, the height. 1/3 base area times height. So that's the formula for finding a tetrahedron. Now, what about a pyramid? What if instead of a triangular base, I have a square base? So then I have a pyramid, right? Can I still use this formula? The answer is yes. You can use that for a normal pyramid as well as for tetrahedron. And like I said just now, you can use that formula for a base of any shape. So for cone-like object, all right, with a pointy tip on top, and with sides coming down straight to the base, and the base can have any shape you like. Now, let's clean this away. Right, we'll look at just one more shape, and this is a very important shape. And I'm not looking at a circle, I want to look at a sphere. So not the circle on a flat piece of paper, but a three-dimensional sphere in space. Alright, a three-dimensional sphere. Okay, so we want to find the volume of the sphere. So let me just maybe draw a little thing there to make it look three-dimensional. Okay, right, so let's say the radius is r. So the formula for the sphere is volume V is equal to 4 over 3 pi r cubed. That's the volume for a sphere. It's slightly more complicated. You have this factor of 4 over 3 that you need to remember, and the r is cubed. Alright, there is a power of 3. So that's the volume of a sphere. You can, as long as you know what r is, if you know the length of r, it might be 3 centimeters, it might be 5 meters. For example, if you know the number for r, you can just substitute it into this formula and calculate an answer for the volume. Now, apart from the volume, another important formula for the sphere is the area on the surface of the sphere. Okay? Now, I'll just call this A. So that's the surface area. Alright, the area of the curved surface around the sphere. And the formula is 4 pi r squared. Right? So instead of 4 over 3, we have a 4 there. We still have the pi. And we have r squared. Right. So that's the formula, 4 pi r squared, for the surface area of a sphere. Okay, well, we'll stop here for this session. See you next time.